Hi, welcome to today's video, which is going to be looking at conjugate acids and bases. Now, the word conjugate comes from the word conjugal, which is basically about a pairing. Okay, so sometimes it's referred to married couples, like they are conjugal, they're conjugate together. Okay, but today we're going to be looking at what we mean by conjugate acids and bases, so how they are paired up. So what you need to think about and remember is that an acid is a proton donor and a base is a proton acceptor. And of course, when we're talking about protons, we mean H+, which is just a hydrogen ion which has lost an electron. Right? That's what we mean by a proton. So I'm going to be starting off with a fairly simple acid-base reaction and talking about what we mean by a conjugate acid and base. And we often talk about conjugate acid-base pairs. All right. So I'm going to start off by just doing something like this. So hydrochloric acid, okay, and I'm going to react that with sodium hydroxide here. Okay. Now that chemical reaction is an acid-base reaction. It's neutralization. So what we get out of that is sodium chloride, a salt, plus water. Okay, so that's an acid-base reaction. That's neutralization. It's exothermic. It releases energy. That's all the sort of things we've been looking at in some of these different videos. Okay, but this reaction, we could actually break this down. Okay, because every acid-base reaction kind of follows the same thing. Okay, it doesn't matter what our acid is and what our base is. We have the same sort of thing that happens. And what happens is that you have a hydrogen here from the acid, and you have the base part, like that, okay? And they react to form water. So it doesn't matter if it's hydrochloric acid, sulfuric acid, nitric acid, whatever. All that other part, that spectator ion does, is create salt. Same with the base. Doesn't matter what the cation is, what the metal is that's in our base, that just reacts to form the salt as well. They're sometimes called spectator ions because they don't really impact what's happening in the overall reaction. So for an acid-base reaction, this is what's happening. H plus OH minus giving us H2O, okay? So I'm going to use that principle there of we've just got a hydrogen here and a base here giving us water to show you what we mean by conjugate acid and base pairs, okay? I mean, it's not surprising. You'd be fine with me saying that H plus is the acid and that OH minus is the base. But what about water? Is that an acid or a base? Okay, well, the answer is actually both, because water can, in solution, do this. H2O can actually form H plus and OH minus, all right? Because that's all water is. It's a hydrogen with an oxygen and another hydrogen in there, okay? So what that's actually showing us is that water is in fact both an acid and a base. Now the term for that is amphiprotic. An amphiprotic substance, and I'll write that down, all right? Amphiprotic substance. An amphiprotic substance is one that can act as an acid or a base. So it can accept protons, which means it's a base, or it can donate protons, which means it's an acid. However, you know that it's not a strong acid or base. Okay, all right? It's not like when you drink water, your insides disintegrate or anything because it's a really strong acid or it's a really strong base. It's quite weak, okay? So we're going to be using that concept as well to explain the whole idea of conjugate acid-base pairs. So let me just rub this out and I'll show you what I mean. Okay, so what I'm going to do is I'm going to stick with that reaction, the H plus, okay, with the OH minus, okay, to give us water. But what I'm going to do is I'm going to show it slightly differently now, okay? What I'm going to do is I'm going to have a product down here, and I'm going to have another one here, okay? So I'm going to obviously need to balance this up a little bit. So we're going to need 2 of these, and we're going to need 2 of these, okay? Just so we've got this reaction all balanced up. So it's just needing to work between some of the pens here, okay? Now, I haven't actually done anything differently from what we just had before of H plus OH minus giving us H2O. But what I want to show is what this idea is of conjugate acid-base pairs, okay? So when this H plus, which is the acid, when that is donated to the OH minus. We form water, okay? Now this H2O is what we call a conjugate base. Now the reason we call it a conjugate base is because if this reaction actually goes in both directions, okay, what it means is that this H2O, okay, could actually accept a proton to form H3O plus. Now, H3O plus is just water with a H plus on it, okay? So that's what we mean by conjugate base. So it's weaker than the original one, but a conjugate base is the base that is formed when the acid donates a proton. In the same way, this over here, the OH minus, that is the base, okay? And what that forms is a conjugate acid over on this side. So this conjugate acid here, the H2O, what that means is that that could actually donate a proton. So if it donates a proton, you then go backwards to get the OH minus. So the conjugate acid or base is the acid or base that is formed from the original acid or base. And I know that's probably a little bit to get your head around to begin with, okay? So I'm going to show you with an actual chemical reaction, a really straightforward one. So hopefully it'll make a little bit more sense. But you might just want to pause and try and understand what I mean here, that this base here can go backwards to form an acid. This acid here can go backwards to form the original base. And these ones are weaker than what we started with, okay? That's the whole concept of conjugate acid base. Let me show you with one more reaction. So I'm going to do this reaction. I'm going to use ammonia, which is NH3, and I'm going to react that with hydrochloric acid, okay? And what we form is ammonium ions and chlorine ions, okay? So we've got NH3, ammonia, which is a base. It has a lone pair of electrons on the nitrogen, which is able to accept an electron. So accept a proton. So this is our base, okay? This base accepts a proton to form NH4 plus. So this NH4 plus is our conjugate acid, okay? So these two are linked, okay? So what that means is that the NH4 plus could, in fact, do this. NH4 plus could actually go back to reform NH3, which is our base that we had up here, and a proton. So there you go. So it's now actually donating a proton, which makes it an acid. That's why it's a conjugate acid. It comes from the base here, okay? But it's much weaker. Ammonia here, the ammonium ion, is a very weak acid. It doesn't readily want to donate a proton away to go back to form ammonia, okay? And hydrochloric acid up here, HCl, okay? HCl here is acid, just here, okay? And that forms our conjugate base over here, which is the chlorine, okay? So that means a chlorine ion could, in fact, accept a proton to reform hydrochloric acid, okay? So because it's accepting a proton, it's a base, but this is a much weaker base than the hydrochloric acid was a strong acid to begin with, okay? So hopefully by now you've kind of got this concept of what a conjugate acid and base is, all right? A conjugate acid or base is the acid or base formed from an original acid or base, and it is weaker than the original form, okay? Might want to just take a little moment, might want to re-go through a couple of things, but hopefully this one here has been able to sort of solidify what we mean by conjugate acid or base. As always, if you've got any questions, just ask. Thanks, guys.